I'm Elizabeth Walquist, and I'll be explaining the series circuit. So basically, the series circuit is all in one loop. It doesn't break off or anything. So for the voltage, to get total voltage, you have to add up the voltage at V1, V2, and V3. So that'd be here, here, and here. For the charge is equal throughout the entire circuit. For the capacitance, you have to take the inverse. So you have to take 1 over C1 plus 1 over C2 plus 1 over C3. And then you take the inverse again to get the final capacitance. So an example, in this circuit, we have 6 microfarads, 9 microfarads, and 2 microfarads, and we have a total of 5 volts. So pretty much, we're gonna solve for Q, which is the charge. So charge equals the equivalent capacitance times the voltage. So we need to find the equivalent capacitance first. So we have to take 1 over 6 plus 1 over 9 plus 1 over 2. That gives us 7 over 9. You take the inverse of that, so you have a total of 1.29 microfarads. And then you plug it into the equation, so you have Q equals 1.29 microfarads times 5 volts. Then you convert the micro to 1.29 times 10 to the negative 6 farads. And then you get a total of 6.45 times 10 to the negative 6 coulombs. So then the total charge on this circuit is 6.45 microcoulombs.
Hey guys, my name is Jordan Edwards, and today I'll be talking to you about capacitors in parallel in a circuit. So for parallel capacitors, our voltage across each capacitor will be the same, and our total charge Q would be the charge of each capacitor added together, and our equivalent capacitance, CEQ, would equal to C1 plus C2 plus C3, and that will get you your equivalent capacitance. And for example, over here, we have a 13 microfarad capacitor, 9 microfarad capacitor, and a 6 microfarad capacitor with 11 volts. So to find our total charge Q on the capacitor is going to be Q equals CEQ times V. And our equivalent capacitance, so what we do is just add up 13, 9, and 6, as you see over here, and we get 28 microfarads. And once we get 28 microfarads, we can just plug it back into our equation, Q equals CV, and which we did right here, and we multiply that by 11 volts, and that will give us 308 times 10 to the negative 6 coulombs because it's in microfarads. So our total charge Q would be 308 microcoulombs.
Hello, my name is Cass, and I'm going to be talking about a circuit where we have capacitors in parallel and at the same time in series, as you can see on this one. Well, in order to approach this problem, you first have to add these two in series and these two in series, which we did right over here. As you can see, we added 1 over 3 plus 1 over 2, which gave us 5 over 6, and then the answer for that is 1.2. And then we did 1 over 4 plus 1 over 5, which gives us 9 over 20, and then you take the inverse of that, and then you get 2.22 microfarads. And then you draw a smaller circuit where you can see that calculation, and at this point the circuit is in parallel, and then you add both of these, which we did down here in the bottom, and you get 3.42 microfarads. So finally, we have to find the charge for the entire circuit, which we did right over here. And as you can see, we draw this little circuit significating it, and then you do 3.42 times 10 to the negative 6 farads times 5 volts, which below here we get the answer, which is 1.71 times 10 to the power of negative 6 coulombs.
Be like, alright. My name is Daniel Doyle, Center for College Engineering. I made the video. I'm just kidding. I'm not doing it. Wait.
Let me.
Wait. You recorded? Yeah, go ahead. You recorded.